Hello everyone, we done project as a team. Myself Sheikh Faizabanu and my teammate yes Lavanya. Our project title is Self-Driving Car Identifying the Traffic Signs. In this era of artificial intelligence, humans are becoming more dependent on technologies, and the companies like Google, Tesla, Mercedes Benz, and many more are working on automatic vehicles. They are trying to make their vehicles more accurate. One such example is the self driving car, as safety is our first priority. So, this is not wrong to think about the safety aspects, a chance of significant accidents from machine. But no machines are more accurate than humans, so the researchers are running many algorithms to ensure 100% road safety and accuracy. One such algorithm is the traffic sign identification. Now let's see what is traffic sign classification. When you go on the road, you see various traffic signs like traffic signals, turn left or turn right, speed limits, no passing of heavy vehicles, no entry, children crossing, etc. that you need to follow for a safe drive. Likewise, autonomous vehicles also have to interpret these signs and make decisions to achieve accuracy. This methodology of recognizing which class a traffic signs belongs to is called traffic sign classification. Our motivation for this project is self-driving cars are becoming more very popular due to efforts of companies like Tesla in automating their electric vehicles. To become level 5 autonomous, these cars would have to correctly identify traffic signs and follow traffic rules. After identifying these traffic signs, it should also be able to take correct decisions suitably. These are our system requirements. We are using TensorFlow model, Matplot library, NumPy, Pandas, and Google Colab. These are the steps we are following while doing our project. First, we are understanding the dataset. After that, we are importing the required libraries and the dataset. We are pre-processing the data and visualizing the data by using Matplot library. And we are training the model and finally model evaluation. This is the flowchart. Our dataset consists of images of traffic signs, and we are dividing those images into separate groups. After that, we are detecting. In the detecting, we are training the dataset. In the recognition process, the machine will recognize and keep tracking of the recognition images with the results from the previous images. Conclusion: we created a TensorFlow model to identify traffic signs. We had observed that the accuracy and loss changes over a large dataset. Thank you. Now the code will be explained by Lavanya.
Hello everyone, I am Lavanya. Now we will see the code for our project. Initially, we have installed the dependencies for this project and I have installed the TensorFlow Hub, which is the most important library used in this project. Here I have imported all the required libraries uh, from this library. To store the output, we have used these lines. We selected the input dataset from the MobileNet network, which consisting of the shape of the image to 224 by 224 pixels, and the input dataset comes from the GTSRB website, which is a German traffic sign recognition benchmark, which having the 50K images and more than 40 classes. To fetch the images from the GTSRB website, we have used these lines to fetch the from training set, and to fetch the from validation data set, we have used this code. The tricky part of the GTSRB is that the images are stored in the form of zip files. So we need to unzipping the files. So to unzip the files, we are using these codes. Actually, the dataset operates on numerical label. Here we make it into the human readable label. The training dataset, which we loaded from the OS, is stored in the form of .ppm files, which is not supported by the TensorFlow. So we need to make it into the .jpg file. So we are converting into the .jpg format. Here we are displaying the images from the dataset, different types of traffic signals. You can see here. All the TensorFlow Hub image modules expects the float inputs from 0 to 1. So we are using the image data generator and rescales to achieve it. Here we are printing the shape of the image batch and label batch from the dataset. Now we are loading the validation dataset. As I said that the dataset is in the form of .ppm files, so we need to convert into the .jpg files. Here we are extracting the featured from the URL, and we are storing it, and we are finding the some making some predictions. We are finding the shape of the prediction dataset. Here we use the compile to configure the training process. Here the training in the training process, I have given the 20 epochs to train the model efficiently. Here we are plotting the graph between accuracy and training steps. The graphs will be seen like this. Coming to the model of evaluation, we are loading the validation data from the .csv files into the pandas data frame, which also changing the file ending from .ppm into the jpg files. Again, we are find out in the shape of the image batch and label batch. Here we are displaying some prediction results. We got the accuracy of 0.875 for the validation for the data set. Here we are calculating the accuracy and losses for the validation data set. Here for the validation data set, we got the loss of 1.31 and accuracy of 0.68. We are to train that validation dataset. We are saving the trained model, and we are converting into the TensorFlow Lite model. And finally, we got the output like this. And now accuracy also same as test dataset 0.875. Here you can see that the detected traffic sign is displayed in green color, which is not detected is displayed